So today I'm going to do another problem from my Leetcoding challenge, and the problem is called valid perfect square. So given a positive integer num, write a function which returns if num is a perfect square, else false. Note, do not use any built-in library functions such as square root. So 16 is a perfect square because 4 square is 16, and 14 is not perfect square because closest perfect square to that is 16 or 9. So in order to do that, what we can do is we can think about binary search. So we know that let me comment. So we know that like the square root of an input. So the input is like a square value. So we know that the square root of that input is in between 0 to that input. So what we can do is we can make an educational guess by trying to guess in the middle. So initially we guess in the middle, and if that value is not the same, we want to keep searching. And in the case that value is less than the input, when we multiply them by each other, when we square it. So when we square the middle value and it's greater than the input, what we want to do is we want to move our boundary. We know that the answer is on the left side, so we need to move our boundary up from the right to the middle. And in the case that the mid value, when we square it, it's it's less than the input. What we want to do is we want to move the left boundary to the middle, because we know that the answer is greater, which is on the right side. So in order to do that, what we need to do is doing binary search. So low is equal to 0, high is equal to none. And what we do is we do while low is less than or equal to high. What we want to do is we want to check if mid is the middle point, and we want to do floor divisions to get a whole number, and the product is equal to mid times mid. So this will give me the square value of that guessing. So if product is equal to num, we want to return true. Otherwise, if product is greater than num, we want to move our high to mid and -1. The reason that we do mid -1 is because we already tested mid, so that's why we want to move to the left one more. We don't want redundant double check mid multiple times. Else, so L in this case it's basically mean that the product is less than num, because we already recheck the condition when product is greater than num and product is equal to num. So this L is basically product less than num. So when product is less than num, we want to move our low to mid +1. So +1 here, the same idea. We don't want to check mid twice, and when we update low, it means that we want to move to the right. We know that the solution is higher. and then here return false. So the idea is like, in order like to figure out if a number is a perfect square or not, what we need to do is, according to this program, we do guess. We keep guessing the number between 0 to num. And the reason is because we know that if we guess number from 0 to num, we know that we will be able to find the answer, because like the square root of num, for like the worst case scenario, it would be the same as num. So like for example, when num is equal to 1, so when num is equal to 1, the square root of 1 is 1, so 1 is also like perfect square. That's like the worst case when the value is equal to like the square value. Other case, it's always lower, it's from 0 to num. And something that we need to consider is, what if the input is negative? So it shouldn't be if the input is valid, because we know that a square of a value, it's always positive. So like for example, a square of 2 is equal to 4. A square of -2 is also equal to 4 too. So our input should always be positive. In the case that it is negative, it means that the input is not valid. Okay, so we shouldn't care about the negative value if we have made an assumption that the input is valid, or we can like check right here. And what else? And let's look at our algorithm one more time. So we have low, start from 0 and to num, and then we do binary search right here. We set that break it when the low and high cross each other. When low is greater than high, we want to stop this program. So we keep like searching. So first we go to the middle, and then we find the perfect square. Then we find the square of that middle, and then we check if that middle square is the same as the input. If it's the same, it means it's a perfect square. And if not, we want to keep like searching either. So right here we want to search to the left, and right here we want to search to the right. That's basically it. Let's try and see if it runs. Alright, finished. Let's submit it. Accept it. Alright, so I hope this video is helpful, and if you guys have any question, please leave down in the comment. Oh wait, regarding to time complexity and space complexity, this is basically just log-in, because it's a binary search, and because every time we go through this loop, we reduce the size of the sample by half. That's why it's log-n or log-n. And for the space complexity, we only use 2 variables. And this is a iterative call. It's not a recursive call. So there shouldn't be any memory for the recursion stack. Alright guys, so that's about it. Hope you guys like it. Bye bye.